Assalamualaikum warahmatullahi wabarakatuh. In this video, you will be dealing with the problems of finding the roots, and in order to do that, you will have um, to factor the polynomials. Okay, so you will be looking at the process of factoring the polynomials and finding the values of x such that when you substitute this value into the polynomial function, the result will be 0. So let us recall the idea of finding the roots of quadratic equation. So quadratic equation is also a type of polynomial function, and in this example we look at this function here, y is equal to x squared minus x minus 2, and this can actually be factorized as x x plus 1 and x minus 2. Okay, so you can check by expanding it and you will get this original expression here. So if you want to find what values of x such that y becomes 0, therefore what you need to do is you set y equals to 0. So therefore x plus 1 x minus 2 is equal to 0, and this gives us two options: either x plus 1 is equal to 0 or x minus 2 is equal to 0. X is equal to negative 1 and x is equal to 2. So these are the 2 points where if you substitute these points into y, into this function, y will become 0. So again, y is the polynomial function, so y is actually px here. So based on the graph given on this figure, you can see that at point x negative 1, the value of this function is 0. And similarly, when x is equal to 2, the value of this function is also 0. So we said that x negative 1 and x equals to 2 are the roots of quadratic equation given. Okay, so now this idea can be extended if you have polynomials with higher degrees. Okay, so these are example of polynomial functions, polynomial graphs. So when you talk about finding the roots of polynomials, you are actually looking to find the values of x such that the value of px, so this is px, the curve here is actually the curve of px. So you are looking to find what values of x such that px here is 0. So based on this graph, I think you can clearly see when x is negative 2, px will be 0. When x is 0, the value of the function is also 0. Px here will be 0. And when x is 1, it is also going to be 0. So we said that these are all the roots of px. Okay, roots of polynomial function. Now similarly here, if you have this polynomial function, polynomial graph, when x is equal to 2, the value is 0. When x is 4, the value is also 0. So x2 and x4 are the roots of this polynomial function. So in this video also, you will be looking at the implementation of long division, which you have seen in the previous video, in order to be able to factorize all the polynomials. Okay, now this is an important theorem, so given in this box here. So basically it says that if the remainder obtained from dividing the polynomial px by x minus a is 0, then the linear term x minus a is called a factor of the polynomial px, and subsequently it means when you substitute a into the polynomial function, the result is going to be 0. Now what it means is that you have polynomial px, so here you have polynomial px, and you're going to divide this polynomial with x minus a, so you're going to divide that with x minus a. So you will find the value on top here, and you go on with the process until the very end, and at the very end the remainder here is 0. So everything is completed, there's nothing left. If that is such a case, then we are saying that x minus a must be a factor of the polynomial. So what it means is x minus a must be equal to 0, and therefore x must be equal to a. So x equals to a, so a is actually the root, okay, one of the root of the polynomial function. So because of that, if you substitute a into the function, so you substitute a into x, you will get pa, and the value is going to be 0. Okay, so that is the meaning of this statement given in the purple box here. Now, based on the above theorem, you can see that if, let's say, you have a polynomial px and you divide that with ax plus b, which is a linear term, therefore, if the remainder is 0, then ax plus b is also termed as a factor of the polynomial px. Again, we talk about the same process where you have the polynomial function and you divide that with ax plus b. So the process going on at the top here, and you continue all the process. Okay, so you continue all the process until the very end, and the remainder is 0. Everything is completed. So if that is the case, we can say that ax plus b is a factor of the polynomial. So it means that ax plus b is equal to 0. So therefore x must be equal to negative b over a. So this is the root. So if you substitute the root into the polynomial function, the result of that will be 0. So this is the similar idea which you have seen in quadratic equation. When you substitute the value of x into the original equation or original quadratic equation, y here will be 0. So the same idea, and it just carried forward or extended in a how do I say this, just got extended in a more general case. Okay, so let's look at example. So the first one is determine if the following linear function, this is a linear function, determine whether this is the factor of the given polynomial here. So this is the polynomial. Okay, we are going to answer the first question. Now, remember that this can be a factor if you divide the polynomial with this linear function and the remainder is 0. So if that is the case, then we can say that x minus 3 is a factor. So I'm going to do just that. I'm going to do the long division process. Again, before you divide with the linear term here, you need to rearrange the expression given here according to the proper order. So now the order will be negative x cubed plus 5x squared minus 7x plus 3, and here is x minus 3. So I need to find a value here such that when I multiply with x, I get negative x cubed. So obviously the choice here will be negative x squared. Negative x squared times x, negative x cubed. Negative x squared times negative 3, positive 3x squared, minus, this term here will be gone. 5 minus 3 will be 2x squared. So negative 7x is coming down, so we have negative 7x here. So I need to find the value here such that when I multiply that with x, I'll get 2x squared. So the choice here would be plus 2x. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Subtract. This term here will be gone. Negative 7 plus 6 will be negative x. Positive 3 is coming down. So next, I have here x negative 3. So I need to find a value here such that when I multiply with x, I get x, or I get negative x. So the answer here will be negative 1. So negative 1 times x, I'll get negative x. Negative 1 times negative 3, I have positive 3. Subtract, and all these will be gone. There is no remainder. And because of that, you can some sort of write down the justification since there is no remainder. Okay, so we can write some justification since there is no remainder. Since the remainder is 0, therefore x minus 3 is a factor of the given polynomial. Yeah. So this could be the solution to question A. Next, let's look at question B. For question B, let's try a different method to demonstrate that this is a factor of the given polynomial. Now, this will become a factor of the given polynomial if I have 2x minus 1 is equal to 0, therefore x must be 1 over 2. Now, this is a factor of the polynomial if I substitute x 1 over 2 into this polynomial function and I get the answer is 0. So we're going to try that now. I'm going to substitute half into this polynomial function. So let's see what is our result. So if the result is 0, that means this is the factor of the given polynomial. So substitute half into this function. This is equal to 2, 1 over 2 to the power of 3 plus 3, 1 over 2 square minus 8, 1 over 2 plus 3. So simplify the process. So we've got 1 over 8, okay, plus 3, 1 over 4, minus 8 over 2 is 4, plus 3. Next to 1 over 8 is 1 over 4, plus 3 over 4, minus 1, negative 4 plus 3 minus 1. 1 over 4 plus 3 over 4 is 4 over 4, which is 1. So this is actually 1. 1 minus 1 is 0, so you will get the answer is 0. And because of that, 2x minus 1 here is the factor of the given polynomials. So you can write down some sort of justification. Okay, so write down just justification to that. So since the polynomial function valued at x half is equal to 0, therefore 2x minus 1 is a factor of the given polynomial. Alright, I guess that's all for now. You will see more examples related to factoring and root of polynomials in the next video. Thank you very much for watching.